And welcome to Ladyada.
Hey everybody, welcome to Ladyada. Me, Ladyada, at my desk with me, Mr. Ladyada, behind the mic and camera control and more. We're kind of wrapping up a pretty hectic week. First week of New Year is always very intense. I think it's been true for everybody.
Yeah, you know those videos that you see every July 3rd where they're like, oh yeah, look, someone accidentally let off all the fireworks at once. Or it's like, oh look, it's a fireworks factory that blew up and all the fireworks happened in 5 seconds.
Yeah.
It's kind of like that. So just a little word to the wise. Pace yourself, everybody. These next few weeks in the United States of America, where we're at, and probably elsewhere, will be tough. There's no way around it. Not going to candy coat it. Be good to each other. Have empathy. I know we're out of spoons, but you just got to do it because we're almost through probably the worst, and it always gets a little bit worse before it gets better. So hang tight. We'll be here. You know we will be. Take it away, Ladyada.
Okay, I want to start with maybe showing off some of the floppy stuff because I'm not going to be doing engineering on the floppy stuff.
Okay, do you want me to show the video from Friday?
Yeah.
Okay, let's kick it off. This is a 1-minute video. We also have a playlist with all 9 videos and then this one. So here is the latest one from Friday. Ladyada, what is this?
This is my pet octopus. No, this is the wiring for the feather floppy stuff that I was working on last week. I'm getting back to it. This is the floppy drive, and this is wonderful, and it worked. But you can tell the wiring is it's a little bit wiry. So I quickly sketched together a featherwing PCB that has all the pins labeled to make wiring a lot neater. So I've got it plugged in now into my Feather M4, and this is the 34-pin interface, and I got this nice cable which has even 8-inch drive and some 5¼ maybe inch drive socket support. And then you can easily debug by plugging into the extra header. So if I want to watch the index pin or the data pins. And best part is it still works. So now I can actually add floppy write support because I feel more confident that my wiring isn't going to be flaky. So then you'll be able to fully duplicate floppy disks.
Okay, that's where we're at.
Yeah,
what's the latest?
Over Christmas and New Year's, I had 7-8 days in a row of not doing meetings and emails as much, and so I had a lot more time to do floppy stuff every single day. And then as the week kind of kicked off, got busy running Adafruit and making sure that the business is running and designing stuff for the business. And not that the floppy stuff isn't important too. I mean, it's electronics. We're going to sell some floppy stuff, but we're going to get back into it. And there's excitement, and then it's going to slow down a little bit.
Yeah, just to be straight up, the health and safety of our team is more important than this floppy project.
Yes.
But, Lady and I have been working on projects for decades, and sometimes they take a while, but we're moving pretty fast. So what do you got?
Okay, so let's go to the overhead. So I'll show the stuff.
Tonight.
Okay, so I've got that feather wing. So this is quite nice now because I can plug in this floppy cable. I got a real floppy cable. And one thing that's nice is this floppy cable also came with a 5.5-inch floppy disk drive connector, and we got a 5.5-inch floppy disk. Sorry, 5.25, 5.25-inch floppy drive. So this is a nice drive in very good condition. It's got the lock and everything. This motor's pretty sweet, and it's got this connector, and it's they use an edge connector with a little notch in it. So there you go. So this is how you would connect.
$5 gets you the entire cable, but you'll only need the edge.
Pretty much. So this is a pretty sweet disk drive. It's in really good condition. Nothing like leaded solder to make sure that your solder joints are nice and shiny and uncorroded after decades. This was made, I think, in 88. This is good. So this should actually just work, although I just got this yesterday, so I haven't had a shot to turn it on. I also have to get myself a 12-volt power supply hooked up together, a
a power jig for this, because unlike the 3.5, the 5 1/4 need both 5 and 12 volts, and they really need that 12 volts for like this like enormous ass stepper motor. I mean, that's bonkers. This is 12 volts, quarter amp, and this is 33 ohms, whatever, do the math. But it's also probably like 12 volts, 1 amp, and then 5 volts, also, you know, half an amp or something for the control circuitry. So there you go. It's going to be pretty cool. I'm excited to get this going this week. So that's the floppy stuff. So I'm glad I got that cable.
Yeah. What else do you want to show? We also have a question that I said that we would answer live on the air tonight in advance. Do you want to do that one now, or do you want to?
Oh yeah. Well, let me just show the last thing. I got my floppy flooper PCB. This is for connecting to those USB floppy. Those USB floppy disk adapters, which are actually a laptop floppy drive connected to a PCB that does like mass storage over IBM 1.44 megabyte MFM formatted floppies only. So, you know, by pulling out the little adapter, and then you connect the FPC of the floppy drive to this, you can then convert it either to 34 pin, because you want something to connect to 34 pin, or a little breakout. Either way, so we'll see. I have to get the connector for this. Is on the way. I'll try it out, and then I'll just verify that laptop floppy drive works fine. And it's interesting because it's kind of hard to get 3.5-inch floppy disks. Like, you can get them, but they're not super available. Whereas a USB floppy drive is really available. And so I was like, well, what's inside of it? And yeah, it's just a laptop floppy disk. So if you can't get one of these large chunky type, just get the USB type, open it up, remove the controller PCB, and then you can do flex level readings if desired. So that's pretty cool. Okay, so that's on the floppy stuff. So yeah, you want to answer this question? We'll get into the QT and then...
Yeah, one of the things I'm going to start to do is we get a lot of questions. We usually answer them over email and everything, or sometimes we'll do in the forums. And then sometimes we do them on video because, like, we're an open source company. And, like, if we can light one candle, it makes another candle brighter, and that candle can light another candle. And so I've just been asking folks, like, hey, like, can we ask your question on air so at least you get to see it and hear it? So this is from Oz. It says that I'll summarize the question they sent in. They're like, I'm about to maybe get an electronics company and move it to New York. And I said, okay, what do you want to know? And the question is, guess I'm curious about the benefits of being here, New York, versus somewhere cheaper, finding space, and what you wish you had known when you were starting. So, Ladyada, let's just start with the benefits of being in New York versus other places, and something you wish you knew, and I have some stuff too that I'll say.
I think the benefits of being in New York, it's a very large economy. There's a lot of people here, so, and it's not hard to get people you want to move to New York, if that makes sense. Like, it can be challenging to convince people to move to somewhere in the middle of nowhere if that's where you're from. But a lot of people live in New York City, or want to live in New York City, or want to visit New York City, and so that's one really big benefit. Trade-off is space is going to be more expensive. You can go to Brooklyn and Queens, and there's some industrial space. But like, we're in one of the last industrial spaces in Manhattan. There's just not that many. So you have to just be kind of smart, and you have to be like compact with space. You have to think hard about how much space you need. I think, there's nothing really that it's like, oh, I wish I knew when I'd started. I think it just takes a lot of work to run a business. But New York City is, even though it's not cheap, it's a lot of people really excited to see New York City businesses. Like, there's a lot of folks who want to support you because you're a local business, and that's really nice.
Okay, for me, one of the reasons that it's good to be in New York is time is money. And when we started Adafruit, it was out of an apartment near where they were building, which is now the Freedom Tower, 1 block away FedEx, 1 block away UPS, 1 block away DHL,
really nice.
1 block away 24/7 CVS, 1 block away Starbucks.
There was J&R. You can get anything, which is at
one block away Radio Shack.
Yeah.
So
nice.
for two quote founders, we were able to get access to everything that normally people would have to hop in a car, spend hours. Also, we had a lot of college age employees that were working part-time with us. We paid great. They really liked the job. They liked the flexibility. And so we were always able to get a huge talent pool if you watch the news, talent pool is tough. We pay more, we give more, we do more, but we also get more. And so I think that's one of the benefits is you have access to so much so instantly. None of our team members drive cars. They're taking public transportation. They're able to do other things. There's eco-friendly versions of companies, and one of the things they always say is public transportation.
Yeah.
New York is public transportation.
Yeah, we don't have to pay for parking. There's no parking lots. It's like, okay, space is more expensive, but I'm not renting a parking lot because nobody drives in, really.
So every subway comes to Adafruit, no matter where we've been. So
and there's great food.
Yeah.
Like, I remember, like, when I worked in Minneapolis, it was like, okay, we're going to go to the TGI Fridays or the Chili's. And it's like, there's, like, so many good independent restaurants and, like, good eateries. I mean, there's chains if you want to go to chains, but if you just want, like, an excellent burrito or, like, a great Cuban sandwich or, like, a Vietnamese pho in the middle of the day, there's one a block away.
Here's the other thing. So what? Come to New York. Maybe you won't make it, but at least you get to say, I tried. And I think that's the thing that matters is everyone should have a New York story. Everyone is running away from or running to something in New York. You'll meet people that you'll know for the rest of your life. You might meet the person that you're going to spend the rest of your life with. New York is a good place. Now, as far as things we wish we knew, I always think about that. And, you know, when we were starting, Lamore would ask me, hey, do you think everything's going to be okay? And I'm like, oh, yeah, one day, you know, we're only shipping 10 orders a day now, but pretty soon it'll be, you know, 10,000 in sometimes a day or a week. And I think one of the things is nothing happens instantly, at least nothing good. So the thing I wish I knew was it's okay if things take a few years instead of a few days. And I would just want to hear that from the future again. Even though I knew it, that's the thing I wish it was like, look, no matter what you think or do, things just take a little bit of time. And that's why we built a solid business, so I was able to take care of people in what I think folks are going to say was one of the hardest time periods in all of our lives, which is now. So, anyways, that's what I would say.
Okay, great. All right, let's go on to the QT Pies that I designed this weekend.
Can I do one more note?
Sure.
Adafruit.com/CircuitPython2020. We're crazy. We like to hear from our community. We like to hear from everybody. Tell us what you want in CircuitPython. Just go to Adafruit.com/CircuitPython2022 and let us know. It's also on Adafruit.com. There's a link right there. Right-hand side. Little box with the same graphic. Please, please, please let us know because we'll actually do it. Okay, Lady, let's do some stuff. So what's up first?
So I designed a bunch of QT Pies, and I also made little diagrams for them, which means I was working on pretty pins. So I took a little screenshot showing the process of taking data sheet information and putting it into a spreadsheet. As I do that, I kind of double check it. And this is what I use to generate the pin diagrams. Next up, I made an NRF52840 STEMMA QT. So this one I didn't finish routing because actually I got all the GPIO routed, but because of the the weird chip style, it's like a dual row QFN. It's just going to take a lot longer for me to route it. I know I'll be able to get it to fit, but it's just kind of like it's kind of not fun. So I put that aside. So next one I did is the ESP32 S3. And this one I did next because the S2, which is in the store now, and actually we're going to make the UFL version next, was pretty easy to do. It was a dual layer, but it was also like a really good chip to do because it's got Wi-Fi and it has USB and it's got enough pins and it's great for CircuitPython or Arduino. The S3.
This is the back of the same one, right?
Yeah, but you can't. The front looks the same.
Oh, you want me to keep it?
Yeah. The S3 is almost identical. It has a dual core, so it's more powerful. It doesn't have a DAC, and it moves around a bunch of pins. And I think there's some peripheral changes. I know this has also got I think the S3 has another low power core inside of it or something. Basically, the S3 is a dual core, which is really nice because it means that you can have all your Wi-Fi stuff handled on one core, and then you have plenty of processor speed left over. And it's the front.
Back?
The front looks the same as the S2, which is why I'm not much to look at. You got the boot button, the reset button, antenna, The STEMMA QT port has 2 different pins, so you get 13 pins total. But other than that, it's pretty much the same as the S2. It's just I just shuffled a couple pins around because the GPIO moved down and something. But so just watch out if you're moving something from the S2 to the S3 chip. The module is almost the same. It's basically the same pinout, but the chip is not quite the same pinout.
Okay, and those who asked.
Then I was like, well, like if I'm doing the S3, why not do the ESP32? And this wasn't possible until there was the Pico version of the ESP32, which is confusing because there's the RP2040 Pico.
Yeah.
But the ESP32 Pico is a 7x7 millimeter 56 pin QFN chip that has psram and flash in it. So this is a 4 megabyte flash, 2 megabyte psram ESP32. But like for folks who use ESP32 or like have projects, like this is going to just work. You know what I mean? Like I like the S2 and I think the S3 is going to be very popular, but there are just thousands and thousands of projects that use the original ESP32, easily tens of thousands of projects. And it has Bluetooth Classic. So I routed out this design. This was a little bit hairy. I started to have to, like, for the S2 and the S3, I didn't use the inner layers. They were pure ground and power planes. But the ESP32, because it has that USB to serial converter chip required, and they don't get any smaller than the CP2102. That is the smallest size that you can get for a USB serial converter that has the DTR and RTS pin, because you need both to do the auto reset. That said, everything else is integrated. Like the crystal is integrated in the ESP32. I put a Pi network on the antenna, but it technically is already in there. Kind of like everything, the pull-ups, all that kind of extra stuff that you'd expect. So another thing, I kind of forgot about the ESP32 is it looks like it has a lot of GPIO, but it actually doesn't. A lot of the pins are taken by the QSPI flash and the psram, and a lot of them are inputs only because they're near the antenna. And so, and I wanted to get the high-speed SPI pins onto the SPI port that clock mostly MISO pins. So they kind of, after I finished it, I was like, oh, shoot, I forgot to do that. I have to reroute the whole thing. But I think there's a couple projects I wanted to do where, I could make, the tiniest little, Sega Genesis emulator or something. And you really do need to have the high-speed SPI for that. You want to be able to drive that TFT at 80 megahertz using the high-speed SPI peripheral. So this was probably going to be the smallest ESP32 full all together, but that actually works without any additional hardware. And even got the battery and ground pads at the top, so you can run off a battery. And the NeoPixel's driven off of the power's driven off of a pin. So I think that this should be able to actually go very low power too. So it'll be interesting to see. So I'm going to order this PCB, and to prototype it, to check my prototype, I made this pinout diagram to kind of help me visualize all the ADCs and the high-speed SPI and the touch pins, and making sure all of them are input and outputs. But I got all 13 GPIO out there, so that was a kind of nice one. And then
all right, well, we have a video message because there's a lot of folks asking about Risc. They want to know, is it good? And here's the answer.
Risc architecture is going to change everything.
Yeah, Risc is good.
Yeah.
I'm Angelina Jolie. No, not really.
No,
so
I wear the dress in this household.
That's right. We both wear dresses when we go.
Yeah.
We go on the roof to our pool date. So having done all the other ESP32s, I was like, well, the last is the C3. And what's interesting is I actually looked at designing a C3 feather a few weeks ago, and I decided, maybe it was 2 months ago, I decided not to, because the C3 has very, very few GPIO pins, 8. It really doesn't have a lot of GPIO pins, and so as a feather, it would be kind of it's sort of like the ESP3266. It's I was like, I don't know if people really want something that is missing so many I/O pins. Although I might change my plans on that. Anyway, so the C3, there's a version that has flash built in. There isn't a version with psram at this time, but it's small. It has a built-in USB to serial converter. It does not have native USB, so it's not going to get supported by CircuitPython. really. I mean, like maybe, but like not super well because it can't show up as a disk drive or act like a keyboard or a mouse. But it is a Risc-V chip, and it's kind of like our first Risc-V. And if you're going to do Risc-V, having one that has Wi-Fi built in is nice. And ironically, I thought this was going to be a really easy route because it's like the chip is pretty small. You don't need a USB serial converter. You don't need a lot of stuff with it. You know, it's pretty simple. But actually, because the pins are so restricted, it was actually tougher than expected. I ended up having to put a lot of stuff on the middle layers because they're just, it's not like, you know, one of the nice things if you have a chip with a lot of pins, you have a lot of flexibility about where, you know, which goes where, because you can just swap pins around until you get a nice, you know, for all the I2C pins, it doesn't matter what you use, so you just pick whatever the closest, easiest route. But with this, a lot of the pins were really restricted because there's not a lot of ADCs. And then some of the pins have special functions, and then like a whole slew of them are used for the internal flash. So, you know, I had to use every single pin, and so actually routing was a little tougher than expected. So it's not even clear. It's not clear that it has a high-speed SPI peripheral. Like some of them are marked HSPI, but I'm almost positive that those are used internally for that internal flash. So, you know, and then the ADCs are fixed, and then I2C isn't special, and the UART pins are on the UART pins. So that's that.
Okay, well, we have a couple questions.
Yeah.
And I'll just go to this because it covers a few things. Quick question, what's the power draw difference between the QT Py, ESP32-S2 and S3? Is one more power efficient? Just curious for wearable projects.
The ESP32, I believe, is the lowest power because I believe you can go down to 30 microamps. Now, I know I've looked at the S2 because I've had to do low power stuff with the S2, like for the mag tag. The S2 does not get lower than like 60 or 70 or 80 microamps. I've never been able to get it below that. I believe the ESP32 in deep sleep can go lower. I think it can go to like 20 or 30. That said, like, that's pretty low. Like, both are extremely low. Like, once you get under 100 microamps, like, you know, that's a very, like, your self-discharge of your lithium polymer battery is greater than 0.1 milliamps.
All right. Great question, Michael. And then SS220 Astro has the question that I was hoping someone would ask because the next answer is a visual answer. So SS220 Astro says, are you planning a feather-like ecosystem for QT Pys? Yeah, we're coming up with a name. Right now we're calling them BFFs. But,
Yes.
But I'll tell you some of the other names in a second. So Ladyada, what's this? And will we have an ecosystem for all the things, accessories, that go onto a QT Py?
Yeah, so like, you know, we designed the trinket a long time ago, and the trinket I really liked, but it was actually a little bit too small. I mean, I'm still going to sell the trinkets, but I don't want to design... The reason I'm able to make all these different QT Pys is because it's just wide enough that you can get more chips to fit, whereas the trinket actually was just mechanically too small and didn't have as many pins, and so like I felt like this... You know, the Shao layout from Seed is actually a better layout. So I was like when I saw it, I was like, oh yeah, that is kind of cute. There's something kind of nice about it. It's kind of squarish, fits in a breadboard. It doesn't have mounting holes, but it's so small, maybe you don't need any. You can just use the pins for mounting holes. So I saw Geek Mom posted on Twitter this really cool ESP32 C3 which had NeoPixels on the back, and I was like, that's a good idea. Like, you know, I could have a PCB that kind of fits on the back of the QT Py, not in the front, because the front has got the buttons and USB and stuff and the antenna. But it could fit on the back, and it would have like a little 5x5 NeoPixel array, a little bit like a microbit, right? And so I did a quick layout, and this would sandwich onto the back, right? And so you would probably use little headers, maybe little headers and spacers to make a little sandwich, like a little skinny sandwich, but then you could add functionality. So I designed a couple of these. Like I'm designing a lithium polymer backpack one because I had like the Pro Trinket backpack, and this is going to be a little similar, but again it fits on the back, not on the front. So not good for projects that are on a breadboard, but could be good for like if you want to make little charms, like little projects that aren't breadboard friendly, but that like, you know, are standalone. So I think I'm going to design a couple of those.
Yeah, so here's the thing, and we open this up to everyone always, because my opinion is a way to get a good idea is to get lots of ideas. So folks on Twitter and other places have come up with some ideas because we were like, well, maybe we'll call them BFFs for now. Sandwiches with slices, booty, chiclets, and then the current popular one is mullet and mullets, and I'll tell you why we can't do it. It is fun to say business in the front, party in the back. Love it. But sometimes, people have made fun of each other because of haircuts and stuff like that. And also, generally mullets, dudes have. So we're trying to find something that's, okay, codename mullet is here. Don't worry about that. We're calling them mullets internally. Fine.
I won't stop you, but I don't think I can have the official name be that.
Yeah, but BFF right now is what we're going for. So QT Py has a BFF. We'll see. But if anyone has some names, Chiclets has a weird trademark history. Stay away from that one. And then Sandwiches and Slices, and there's a bunch of other ones that folks are talking about. But thanks for thinking of these, folks. Really appreciate it. But we're not going to call it a shield. Not going to call it wing. Not going to call it a hat. Not going to call it capes. But I think right now BFFs is at least where we can bring the most people together, and that's what we try to do with a lot of stuff we do. Okay.
So that's going to lead into the Great Search.
Let's do the Great Search.
Where in the world is that part I need? The Great Search with Digikey.
The Great Search brought to you by Digikey and Adafruit. Every single week, Ladyada uses her power of engineering to find stuff online at digikey.com. And guess what? It's hard to find stuff. We've been doing this before there was a part shortage. We'll be doing this after Ladyada. What is the Great Search of the week this week?
Okay. This week, I'm looking for a new part that I'm going to put on my ESP32 QT Py. Do you mind clicking on the Pico board? I can in the back of it. The left.
This one?
Left. One more.
This one?
Bang. Okay, so the ESP32 is a kind of interesting chip because it doesn't have native USB. So you've got to add a USB serial converter, and that's the second chip, the one in the kind of the middle top there. The ESP32 is the thing on the bottom. So we've got a CP2102, and we covered the CP2102 as a USB serial converter, like a low-cost, small USB serial converter, and that's all good. But there's another little thing. Not only do you need the USB serial for RX and TX data, but by doing this kind of funky trick with two NPN transistors, you can use the pulses from the RTS and DTR lines on the USB serial converter to reset the ESP32 into bootloader mode. And this is similar to if you have an Arduino. The Arduino also used RTS or DTR to toggle the reset line to kind of auto reset the board from USB serial converters. For the ESP32, they didn't connect the DTR and RTS directly. Instead, they have this little transistor like flippy floppy thingy going on there, which I once analyzed and then I've totally forgotten how it works. So let's go to the computer and I will pop up the schematic and I'll show you the parts. So this is what it looks like. You connect, there's IO0 is the bootloader pin and reset is the reset pin for the chip. And then RTS and DTR, when they do a little toggle, they will lower the IO0 pin, which tells it to go to bootloader mode on reset, and then it quickly toggles the reset pin to set it to reset. It comes out of reset, IO0 is still low, it knows it should go into bootloader mode. So the only thing is I need to get a dual NPN. Now I've got N-channel FETs here, but you can't use N-channel FETs. I've never actually tried it, but like every schematic from Espressif uses 2 NPNs. So I'm going to assume you need NPN. That said, I do like the dual BSS that we use on a lot of our boards. It's this part here, and it's nice and small. These are 0402 resistors. This is a TSOP6, also known as a SOP363. It's finer pitched than a SOP236, which is a SOP23 is, I'll show you. So this is a SOP23 size. So it's significantly larger. I'll use a SOP23 for a power supply, but for something that's not using a lot of power, like this dual FET thing, a SOP363 is perfectly fine. And you actually can solder them by hand. Like they're fine pitch, but they're 0.5 millimeters, so they're not going to kill you. You can hand solder them. we use them by like the hundreds of thousands. Every STEMMA QT board, we include a dual FET to do the level shifting for I2C, and so we stock thousands of them. But again, those are BSS138 N-channel FETs. This time we want dual NPN. So let's go to Digikey. First up, I want to mention, so this is the dual FET that we use, BSS138 BKS. We have 250,000 stock because we actually go through like 10,000 a day easily. Because there's like 2 or 3 on like almost every single board that we make. So this very small part, and this is the part, and I actually couldn't remember the name of the package. So what I did, I was like, if I want something in the same package, I'll actually look up what Digikey calls the package, and then it'll just make it a little easier for me to find the part. So this is called this has multiple names, and that's not unusual. Sometimes when they get these small chips, they have different names. So this is called a 6T SOP, or SC88, or a SOP 363. So good to know. Anyway, so what we want is a dual NPN. Pardon me. There's a couple NPNs. Just be careful, because I actually accidentally went to single. Like I went to single first, and I started searching. You can't. You have to go to arrays. And NPNs come in a couple different configurations, so it's not a big deal. Just watch out for it. Sometimes they do you a favor by connecting stuff inside, but we want 2 completely separate NPN transistors. And again, for most of our ESP32 boards, we just have 2 SOT23s, but we just don't have any space on this board. It's so small, I have to go with the SOT 363. So let's go with in stock active. And then let's look at that package. So again, I like the package that I've got the BSS138 in, which is a 6T SOP SC88 363. There's probably smaller, but this is pretty small. I think like a UDFN would be smaller, but I like things with pads, for stuff this small. Okay, so let's apply. Oh, one thing to, because I picked something with 6 pads, I sort of solved one problem, but if you look at the configuration, you can get common emitter. Common emitter means the emitters connect together. This is really good for differential measurements or amplifiers. There's quad, of course, and then there's matched pair and non-matched. Matched pair, like it means that they're guaranteed to be within a certain percentage of the same VBE, like whatever, like the amount of current that they're going to pass and the voltage offset you're going to get. Like they're going to act very similar, and again, that makes it better for differential signal measurements. In this case, it doesn't matter because again, we're using them totally separate, but also we don't want common emitter. So I don't mind looking for matched pair, but usually you have to pay a little bit more for matched pairs. If you do synthesizers, you're going to constantly be doing matched pair stuff, but I'm not doing synthesizers. I'm doing a QT Py, so that's cool. Okay, back to this. Once I select that, there's only matched pair, non-matched pair, which I don't care about. And then when I go down here, I sorted by price just to see like, okay, well, how much am I going to pay for these? And one thing I noticed is that the ones that are the least expensive, like these PUM X2s from Nexperia, they have a min quantity, and there's no way to like not select. I don't know that there's a way to select something that doesn't have a min quantity, but if you click here, you can only buy this by the reel. Like if I try to buy 300, it's going to say no. So that's not like a bad thing. Like I might use these, but if I'm going to get samples, which is what I'm doing right now, I want to get something where I don't have to purchase a large quantity. So for example, like this has a minimum quantity of like 4,000, and I don't want to buy 4,000. So what I did is when I got to these 2 on semis, this BC84-7, these are the ones where I saw like, oh, they have plenty in stock. There's 2 versions. There's one from Panjit, and there's one from, there's a couple from Panjit and one from Onsemi. And these have a minimum quantity of only 1. So, it's tough because the other ones are much less expensive, although it's, minimum quantity, and maybe at the minimum quantity, or the quantity I need, it'll be about the same. but I'm getting only samples right now anyways. So I order the samples when I get the PCBs on order. So by the time the PCBs make it to me, I've got all the components. But these are in stock, and they look just fine. So I'm going to pick these up. I'm going to try them out. And, nothing really beats just soldering them into a circuit with an ESP32 and just checking that it works. But I'm pretty confident it will. Like, the ESP32 reset circuit is, like, very well tested and tried. So even though I've never tried this particular transistor, they have the voltage limits are reasonable. The current collector, the current max current to the collector is reasonable. The DC gain is reasonable. Everything. This is a very jelly bean part, so no reason why it won't work. So I'm gonna pick up 50 of these and get ready for when my ESP32 QT Py arrives. This is the one part that I don't already have stocked.
And that's a great search.
Where in the world is that part I need? The great search with Digikey.
All right, I got some breaking news.
What's breaking news?
Well, first off, I saw Geek Mom in the chat. Thanks, Geek Mom, for stopping by and coming up with some fun names and more. And publishing your projects. We love seeing your stuff. Thank you. So someone came up with a name in the chat. This was from Tackle the World. Sprinkles. That's kind of nice.
Sprinkles, okay.
Sprinkles. Because QT Py seems to have, that's cute. It's like a cupcake. It's like a little cute thing. Like maybe you put sprinkles on
like
top.
frostings?
You put
Okay.
sprinkles on top.
Okay.
Yeah. But, nice, friendly terminology, sprinkles.
Okay.
Yeah, so we'll see. BFF fits on the board. These are tiny boards.
Yeah, these are small. I've got a couple
we'll see.
more I'll be posting over the week. I designed a couple more, and I have some ideas for them. But I actually have a project. What's funny is what kind of prompted the QT Py ESP32 is I needed a project with a Bluetooth Classic chip. And then I realized, like, I don't have anything really tiny that does Bluetooth Classic. And so I was like,
Yeah.
ESP32 is one of those few chips that can do Bluetooth too. It's dead, but it's kind of not dead. A lot of things still use Bluetooth Classic, like a lot.
All right, everybody, that's the show for tonight. Thank you so much for joining us and being part of this adventure. We're going to keep doing this thing, and we're not going to stop. And if we can do it, you can. If we can make it in New York, so can you. If you can make it here, you can make it anywhere. We'll see everybody during the week. We have our entire set of shows that we do every single week. Tuesday, JP. Wednesday, Pedro. Also, Ladyada and I with Show and Tell. And then Ask an Engineer. We might have to move stuff around. Who knows? These weeks are trying. Just as someone who helps run a company with Ladyada, this is as hard as when COVID first started in mid-March. The gymnastics we do on a daily basis, we take really good care of our team, so we just have to do a lot. Sometimes people, this is devastating news. One of their kids tests positive and they have to do a bunch of stuff, and they just need someone to talk to them on the phone. And that's my job.
That's your job.
And I can help them through it. And so sometimes we move shows around and stuff. It's not because we don't want to do it, just sometimes we just run out of time. And more so we appreciate the support and patience that you have. On Thursday, another JP show, and then Friday, Deep Dive with Scott. We'll keep doing this stuff. Thank you, everyone, so much for supporting us. Please pick up something in our store. It helps a lot.
It does. that goes straight into paying everybody.
Yeah, the money goes directly from you to pay our team and the bills and the inventory, and that's it. That's all we do. All right. So we'll see everybody next week. Thank you so much.
Thanks, everybody.